In this video, I would like to present to you the new software I've created, which is called KherveSheet, and it's actually a replica of Excel, but I have tried to make it Excel made for scientists, and I will explain all the differences in this video. So, I love Excel. I love this ideas of having grids, a simple workbook where you can enter data and do some math and even plot. The problem I find with Excel is that the plots are not publishable or are too simple and frankly seems to be made for finance. So it's not made for scientists, I find. And I also do not like the ribbon. So I've created just a small toolbar where not a third of your screen is taken by this useless ribbon. So this program was designed to be as simple as Excel, but could create scientific plot like Origin does. So we all use Origin because we can't create the plots that on Excel. So we use Origin. And so some ideas come from Origin, and then um, most of the other ideas come from Excel. So I liked it. I've started creating, so just to create plots, but I liked it so much that I started adding Python ability also into each cell. So this is, for example, a Python program, and then even AI assistant on the right side. So the AI assistant is mainly to create your own Python program. So I realized that people are not really capable of creating a Python program. So for example, here I will show you. So this is one of the examples, which is in the examples menu. So I have around 300 examples that are all based, mainly all based on science and materials, on physics, on chemistry. But there are some also which are based on live data like weather, earth, and I will show that later. And this, you can create standard still um, non-changing Python programs, but also, and this is my Python cell, so you can see it here, but also you can create live by just a loop that keep changing, for example, some of the cells. So this is the frame rate has been done by zero point 0.1 in here, and then the number of frame is 1,700. So for example, in here, I will use the AI and I will tell him to change the program in here and maybe changing the balls to all be orange, just to show that this works well. So I did write that before, so I can go back with my app and I can go back to many history I had. But for example, in E3, this is what I've written here. In E3, I have a Python program. Can you change the particles to be all orange? Then I click play, and he will use, in this case, he will use my Claude, my Anthropic model, and he's reading the Python programs inside here, and now you can see they're all orange. So he managed to read the Python program and change it within the plot. So the AI assistant has access to my program API and can change anything. But I would recommend really to stay on the Python program because that's what makes sense. So you don't need to use Claude. You can use different provider. So you can use OpenAI, ChatGPT, but those, to get the API, you have to pay for using the API. But the Mistral give you a lot of free amounts. So I would recommend Mistral and especially the Destral because that should be cheaper than the standard open open Mistral. Sorry, the standard large Mistral latest. And you can get more by just refreshing like this. So I've refreshed now, and this is giving you the whole amount that they provide. Okay, so it's quite a lot of them. As I said, I recommend the Destral latest. That's more than sufficient, and so you're not going to use all your tokens on that. As I said, free tokens. So again, one of the examples. I will show you, for example, a non-Python one. So this is just the worked examples on all the non-Python ones. So this is an Arrhenius plots. You may use it, you may not, but it's to show you what you can create on KherveSheet. So for example, in here, you have a way to create nodes. The nodes are all shown in, let me just see, yeah, in here, the nodes. So you can create all those on this will just do something like those ones. You can even change them by just going into edit node in here and just change whatever values, yeah? So this is an equation and that looks like it's a picture, but actually it's not. It's editable. You can add, for example, you can add plus in here. You will see the plus, and you add this, and it looks like it's an error, but you can just add something in the fraction. So it's latex type equation, and now you have it written like this. And obviously, this is not the equation, but this is what you can do. You can do equations, and obviously the cells can be dependent on each other. Okay, so one of this example, let me go to the kind of fancy type examples. I will go again to the live data just to show again the capability. So here I've put a representation of the Earth, and it shows the sunrise and sunset, and it turns around. You can increase, decrease the speed. This was done maybe not with 0.1 seconds. So again, in here, 0.1 second. I'm not too sure how fast, but you can see now it's going way faster. And you can maybe change even the amount of degree even quicker if you like. You can stop it. And to see the program, you can pop out, and this gives you a nice Python editor. So to make this took 200 lines. And as I said, you can increase, decrease, you can change that using the Python chat. So this is how you interact with the grid. So KS is what we call the grid, and that's how we get to B3, B4, B5, B6. Okay, so what else I've added? For example, something that I personally work a lot in is the peak fitting in XPS. So I've created one peak fitting where, let me just delete this one, it's too many. So this is taken from this data. I go from this data, and the plot is actually, or the curve fitting is done using this Python program. And this Python program in here go through the data, but you also look at all those cells. You don't need to create just two picks. You can create more than two picks, and you can also create constraints, as you can see here. Those are the constraints. So this is one way of creating pick fitting using Python and through the cells. I have done another type, and let me open that later. For now, I'll show you some live data. So if I do live data and I do the weather, now you have a graph in here showing you today what's going to be in London, how the temperature will go up and down on the 7 days forecast. And you also have what is going to be today and the next 7 days in a cell. So as you can see, if I click here and then on there, you can see them just being able to be added. So this will add all the rows here. Okay, so another things, for example, live data, I went on just to show the Bitcoin price, which actually just fall recently, and even simulations. For example, we have other type of simulation. I'm not going to go through all, maybe physics simulations, projectile, radioactive decay. That's it. So just things that sometimes I'm not too aware. So the AI did it for me by using this AI chat. Okay, so another things that I've added for scientists is I go back to the XPS again. Yes. Okay, so I mentioned the plots. So those plots, they are now just plotting this thing here, and you can see the quality of the plot. They don't look like um, like the normal Excel. They will look like what Matplotlib can do. So you can double click, and then you have something looking like origin. So this is the axis property, and I can axis, obviously the left axis on the bottom axis in here, and the bottom axis also give you access to the top axis. So I can add some ticks like so. I can do the same for the left, where I'm going to have access to the right, and let me add this time a label, and you can see written there. Okay, and even the title, I'm not too sure if it's going to add up in here. So this is within the margin, it's a bit further, so I will have to change the margin to be able to access this. Maybe something like this. Yeah, okay, it's not shown here. Ah, yes, sorry, the title was not written, and nothing written in the right axis. I think that was it. There was no title. Okay, so again, this is a plot. I don't think you can create using Excel. But another thing that I've added is this peak fitting window. So this is already taken now from KherveSheet. So now it has access. Let me just go through here. Yeah, that's it. So let's say you start from here. I'm going to select my X, this one. I'm going to select my Y. It's done. And here I've got my range, which now I can create a background. I've created different type of background, not just for XPS. You see a polynomial, Shirley, so active Shirley, and I like the active Shirley at the moment. There is also the asymmetric least square for the Raman type spectrum. Okay, so that's done with the active Shirley. And here I've created two picks. I've added two picks because this is what I get, a doublet on the strontium 3D. And I can add different types. As you can see, it's not just XPS, but many different types. Whatever LM fits, so this is the library I use, allow me to do plus more. So right now I use the pseudo void. This is the best really for something as simple as that. And then I have this table, and if you go to pick 2, you can see that pick 2 is in function of, sorry, pick 1 is in function of pick 0 by this expression. And so when you fit, you get this data, it's nicely fitted, let's say. I mean, maybe something here not as good, but you can apply now and you get all this data now added, which is this belongs to that, this belongs to that. So again, something you could use, something that is not really on Excel. There's an equation solver here. And I think now if I just show you the basic of Excel, so of course, if it's Excel, it needs to be able to do what Excel does. So for example, I get 1, 2, 3. I can then use those cells, propagate. I get that. I can now use my equal on this on my function cell. It create equal. I can move with my left arrow to just change the cell. So equal D14. Maybe I'm just going to do something like a square times D14 again. Yeah, and now I get that, and I can propagate by double clicking, just like Excel would do. And I can even propagate the column this way, and I'm getting this monstrous amount. Maybe I should not really do that much. Let me remove this really. Okay, so now you get that. You can also put, let's say, a title, which I'll create ABC, and maybe just put it that way. Okay, so let's say that way. So now what can you do? So this is my X. On origin, you would just right click, and that's what I did, plot, and now you get this plotting. That may not be the best um, way to show plots, so let me redo it again. Let me remove those for now. Let me just create a simple one where I just do times 2, and then just going to propagate and propagate in here. Yeah, it's going to be much easier to plot and to show you what you can do. And now let me just plot this and line, and now you can see that they are all in functions. So this is kind of what you would see. So for example, this one here, I can move it and you can see it disappearing. Okay, it's not easy to see when it's selected as well. So it's easily showing you 0, and I go on there and it's there. I can move up and you can see it changing, and so on. But if I want to make it in function of X, on origin, we would do something like set as X. And now if I just plot those ones, it will then know that those are X values. Okay, so now I may have to change that to maybe something else like 20, and obviously you can see them just changing quite a lot. So 21, and maybe that's it, so 21, and now maybe refresh the plot, update the plot. You can see them all being changed to what I've mentioned here. So this one, actually, I have just created something, T4 times 2, 20, yeah. Okay, so it may need to be re-updated. That's it, update plot. Okay, so now you see the type of, that it's exactly like Excel. So another things that I have added, which I think is also useful, is a layout. So now a layout would have the plot that we've just created and actually all the plots that we create. So in here, we could deselect and you just get one here. Currently, it's just this one. Let me just change the right so that looks at least inside, and maybe this also inside. And so now when you do it, it just looked inside. Okay, so if I was to add a new plot, let me just do another one, maybe in here, equal this value times maybe 0 0.5, oh, sorry, power 0 0.5, so square root, yeah, and maybe just plot that, and maybe scatter this time. Then you now get in the layout, you get a third one. And again, you can just remove one if you like, or add it. You can change the size, so the figure size is shown here from different papers. And if you want to add some arrow, you can just go in here, do something, do as you wish. You can also add annotation inside the plot. So let's say I put a test 1. This is my text. This will be appearing in here. And if I go to layout, you can also see it. Okay, so this all those things I've added. There is more for you to check, but it shows you the strength of this Excel for scientists.